Hello, fifth hour intermediate algebra students. So here's the video that I promised you to show you what I would have been doing online if my internet had not gone out. So we kind of started by talking about the properties that we learned in 6.1a, which is that if we have two bases that are the same on both sides of an equation, we can set the exponents equal to each other. We also then quickly reviewed what happens when there's two things on the same side. What we had just started doing is this problem, 2 to the 4x equals 8 to the 12. In order to be able to solve this, though, the problem is that if these have two different bases, a 2 and an 8, I can't just set their exponents equal to each other. I need to make them have the same base. That is a two-step process. First, you need to identify the larger base. So in this case, the larger base was 8. Second, you're going to make that base, so the 8, equal to the base you want, which is 2, to some exponent. Okay, so you set it up like that, and then you figure out what needs to go in the exponent. So 8 is 2 to what power? Well, 2 times 2 is 4, times 2 is 8. So it's 2 to the third. Okay, so that's why I replaced the 8 with 2 to the third. Okay, now the next step that we needed to learn, so that was the first new thing in section 6.1b. The other new thing was that in order to figure out what 2 to the third to the 12th is, we need to know one more property. And Ms. Krebsted in her video had showed that if we had like x squared cubed, that would be like multiplying x squared by itself 3 times. And then based on what we just talked about up here in number 2, if we have the same base multiplied together, we would add those exponents. So in her video, she went through and showed you that this would be x to the 6th. Having said that, if we look at this, that means that if you have x to the 2 to the third, it's the same as x to the 6th. We get there by multiplying the exponents. So if you ever have an exponent to an exponent or a power to a power, you multiply them together. Okay, so that was the third and final property that we talked about in 6.1b. So now I would get 2 to the 4x equals 3 times 12 is 2 to the 36. And now I can set those exponents equal to each other. So 4x equals 36, divide by 4, x equals 9. Okay, I want to do just one more. And this one actually was in the video, but just in case you've forgotten about it. The second example I want to do of this is if we were given 7 to the 10th equal to 49 to the x plus 1. Okay, the first thing I would do is again take the larger number, so the 49, and I need to set it equal to the base that I want, which is 7, to some exponent. So again, I think about 7 times itself. How many times is 49? Well, 7 times 7 is 49, so squared. Okay, so my first step is the same as what we just talked about. I changed 49 to 7 squared. But here's why I wanted to look at this one. What we just learned is that if we have a power to a power, or an exponent to an exponent, meaning that you just have the parenthesis between them, we need to multiply those. Here's the key though. You are taking it to the x plus 1. You have to take it to both of those pieces, which means you need to distribute. So it's 7 to the 2x plus 2. The common mistake is that people would have a 1 here instead of a 2. So just be careful with that. Make sure if there's multiple pieces in one of the exponents, you use distribution. Having said that, now I can set 10 equal to 2x plus 2, and then I would just use my algebra to solve. So this was the review we were going to do of section 6.1b. Again, that was from last week, your asynchronous stuff. The new stuff, in case you had a hard time when you were doing your 6.2b practice, this is what you need to know from that. So in 6.2b, we are writing exponential functions. So to do that well, we want to review what we talked about yesterday. An exponential function is of the form y equals ab to the x, where the a we said is the initial amount. So again, we actually wrote that down yesterday, which then on a graph is the y-intercept. The thing I added for students today is that the y-intercept happens when x equals 0, because that's going to be helpful when we're given a table or ordered pairs, because we need to be able to decide what the a is. That should be quick and easy. Just look for when x is 0 or where it crosses y-axis. The b is this thing called the common ratio. We wrote that down yesterday. Now the common ratio, though, is what you multiply by over and over again to get from one y to the next. So it's going to be the y values. We'll talk about that. Okay, so it's what you're multiplying by over and over again. And that's why these are exponential, because when I multiply by the same thing over and over again, that's taking something to an exponent. Now, yesterday we did write down that if that common ratio is greater than 1, so if b is greater than 1, it's going to be growth. You don't need to know this for today, but it's good review. And the graph looks like this. If b is between 0 and 1, it's going to be decay, and it's going to look like this. Okay? Now, from yesterday, so just so we've reviewed all of 6.2, remember, we want to be able to find the domain, the range, and the asymptote. But here's the key, you guys. Whether it is growth or decay, if it is just an exponential function in a b to the x form, these three things are always the same. So for both of these graphs, the domain is all real numbers. The range is y greater than 0, and the asymptote is y equals 0. Okay, so those are all the same. That's what we did yesterday. Okay, if you don't have this down, pause it, make sure you get it down, because now we're just going to do a couple of examples. So the first one is, looking at the table, write the function. Remember, we need f of x equals a times b to the x. We just said a is when x equals 0. So I look at my table, I find my x's, I find when x equals 0, and my a equals 6. So I'm going to have 6 times something to the x. My b, remember, is what y is multiplying by. Now, I could look at 0.375 to 1.5 and say, what am I multiplying by? And I'm not sure. So if I find two numbers like 6 to 24, I know to get from 6 to 24, I'm multiplying by 4. And then I could just check it. 24 to 9 is times 4. This is times 4. This is times 4. So my b value is 4. So 6 times 4 to the x is my answer. Now sometimes that b isn't going to be able to be seen by what am I multiplying by, which means then we'd want to work backwards. So if you can't tell by looking at it what you're multiplying by to get from one to the next, then you're going to work backwards. I can take the second y and divide by the first y. So to work backwards, you would divide, and that gives me 4. I could take 6 divided by 1.5, and that gives me 4. 24 divided by 6. Okay, so you can always work backwards, and then you're dividing. Okay, so to find b algebraically, take your second y divided by your first y, and that'll give it to you. Okay, and then you'd have to keep going to make sure it's consistent. All right, so that's if you're given a table. If you're given a graph, you're doing the same thing. But if I'm looking for the a value, remember that's my y-intercept, because again, I'm doing f of x equals ab to the x. Well, here, I can see it's right here. My y-intercept is 3 times b to the x. Well, for my b's, again, I compare my y value. So really, this is just giving me 4 points. So to get from 3 to 12, well, that I know I multiply by 12. I mean, by 4, sorry. 12 to 48 times 4. This is also times 4. So my answer is 3 times 4 to the x. Again, I could have done 12 divided by 3, which gives me 4. And last, this one is actually very similar to the next one since we wrote the 4 ordered pairs here. We could also give you the ordered pairs this way. Again, I would look for when x is 0. So my a is 27. Now this one I had people type in the chat their answer in my other classes, and almost everybody got it wrong. Most people put 3. But remember, you're asking yourself 27 times what is 9. You have to work this way. So it's not 3. Again, if I'm not sure, I divide going this way, meaning I would do 9 divided by 27. And if I reduce that, they're both divisible by 9, so I get 1/3. Okay, so just be careful with the fractions. Now again, I see that 27 to 9 to 3 is going down, so it should make sense that, my b is between, b is between 0 and 1 because it's decay, it's decreasing. All right, the last thing that the video in section 1 reviewed was that exponential functions happen when you are multiplying by the same thing over and over again. Okay, and we said that's called the common ratio. Okay, in the first chapter, we actually talked about linear situations, and that's when you're adding the same thing over and over again. Back then, we called that the common difference. And the reason I bring this up is because the last thing we want to be able to do from this section is, given a real world scenario, you need to be able to decide if it's exponential or linear. Okay, so when we look at these two problems, we're going to identify it as linear or exponential. Number 1 says a library has 8,000 books. It's adding 500 more books each year. So thinking about what I just heard, I see adding 500. And again, as soon as it's adding, that means it's linear. The second one says a bank account starts with $10. Every month, the amount of money in the account is tripled. Tripled means multiplied by 3. So because we're multiplying by the same thing, this one is exponential. All right, that was everything I was supposed to do with you in class today. Again, I apologize for my internet. Tomorrow, make sure you do your 6-2 Pearson lesson quiz, and I will see you live on Thursday. Thanks.